Hey! Welcome to the 12th lesson on C++. Throughout this lesson, we will explore the topics of references and pointers in the C++ programming language. First, let's understand what references are. To grasp this concept, let's create a variable. Let it be an int variable named number, and let's give it a value of 10. Currently, we have created a variable that occupies a memory cell in the computer's RAM, taking up 4 bytes of memory. Now, imagine I want to create another variable, and for its value, I want to specify the value of the previous variable. Of course, I can write it in the format I just used. However, you should now understand that when I create a new variable and assign it the value of the previous variable, this new variable is also stored in the computer's memory, occupying another cell, and this cell is 4 bytes as well. In other words, currently, our program would occupy 8 bytes in RAM, 4 bytes for one variable and 4 bytes for the second. Every time you need a variable to store the value of another variable, it's not quite logical to write code as I just did. The issue is that when we write code in this way, we essentially duplicate the occupied memory. In such cases, it is convenient to use references. To create a reference from a variable, we need to place an ampersand before the variable, and now, this thing is essentially not a variable but a reference. What is a reference? A reference is essentially the same as a variable, with the only difference being that our reference now doesn't point to the value stored in the numbers variable, but instead points only to the address, where the variable itself is stored. What does this give us? It allows our variable to occupy slightly less of the computer's RAM since it now stores only the address, where the numbers variable is stored. When we have this address, where the previous variable is stored, we can access this address, and the computer will immediately provide us with the value stored at that address in that cell. The advantage is that now we are not storing the value but the address. An address is always smaller than the value stored in a variable. When working with large objects and data arrays, using references and pointers is justified. In such cases, if we had a large data array and simply copied it to a new variable, we would double the memory usage. For example, if it occupied 500 bytes, copying it would result in 1000 bytes. Agree that this is not very efficient. However, when we use references, the first array occupies 500 bytes, and in the end, we get not 1000 bytes but 504 bytes. To make it more visual, let's try to display the clear address of our variable. To display the clear address of any variable, we simply need to write an ampersand before its name. In this case, we are not referring to the specific value of the variable but to the name of the cell where this variable is stored. In the same format, let's output the programmatic address of our reference. To do this, we also append an ampersand. If you run something like this, you will notice that these addresses will match. In other words, our variable is stored in a specific cell, and our reference contains the same cell as our variable. Additionally, let's output the value of our variable here. Doing this is very simple, just write the variable's name. On the second line, let's also try to output the value of our reference. If we run this now, we will see that for the variable and the reference, there will be the same value. Moreover, if you try to change the value for the reference now, let's set its value to 15, if I run this program now, we will see that this value has changed not only for the reference but also for the variable itself. And this is quite logical. Again, we are not storing the actual value in the reference, we only store the address of the variable. When we, through the reference, change some value, we are essentially accessing the necessary cell and changing the value there. In our case, we accessed the number variable and changed its value. That's why the values for both the variable and the reference changed. So, references are essentially constructs that allow us to store the programmatic address of a certain variable, array, or object. Now, let's consider another important topic, pointers. In reality, pointers and references are very similar to each other. That is, their working principle is approximately the same. References store the programmatic address, and pointers point us to that programmatic address. The wording is a bit different, but in fact, they do the same thing. Both are convenient when we need to store the value of one variable in another variable without copying that value. We either reference or point to the programmatic address of another variable. I should note right away that pointers are more versatile than references. For example, we can create a pointer without assigning anything to it. If we talk about references, we cannot create a reference without assigning anything to it. See, if we remove the value, it will be highlighted as an error. But we can create an empty pointer. Also, we can clear a pointer at any time. Additionally, pointers are convenient because we can shift the pointer. For instance, if we were referencing the first cell, then we add 1 to the pointer, and now we are referencing the second cell. This can be useful when working with an array. In an array, we have multiple elements, and through the pointer, we say that we are currently pointing to the first element of the array. Then we add 1, 2, 3, 4, and so on to the pointer. Each time we add a value to the pointer, we essentially shift it and start pointing to the subsequent elements of the array. We will look at all of this in practice. For now, let's see how we can create a pointer. Let's work with a variable. Let this variable be named val, and we'll assign the value 12 to it. Right now, it's just a regular variable. Now, let's create a pointer for it. To do this, we specify the data type, and then, unlike references, we use an asterisk and provide a name for our pointer. The name can be anything, but very often, in the name, 3 characters are used: PTR, an abbreviation for pointer. Let me name it that way, appending the variable name. So, it will be ptrval. And by the way, one more detail I forgot to mention is that our symbols, like ampersand or asterisk, can be written either before the reference or pointer name or immediately after the data type. Both ways will work correctly. However, it's more common that if we're talking about references, the ampersand is written immediately before the name of the reference. If we're talking about pointers, the asterisk is usually placed after the data type. So, here you go. Now, we've created a variable and also a pointer. Immediately, we can notice a difference. I didn't set anything for the pointer, but there is no error. It means you can easily create a pointer that doesn't point to anything. Next, we can say that our pointer will indeed point to something. To do this, we access the variable, and unlike references where we could just use the variable's name, here we need to access the programmatic name of the cell where the variable itself is stored. In fact, we use the ampersand here as well. So, here we've specified a pointer that will point to the programmatic cell where the variable val is stored. Now, for clarity, let's try to do the same things for outputting information as before. That is, in the first line, we'll try to output the val, the programmatic address, and also try to output the actual value in this variable. Similarly, we'll output the PTR value. I just want to display what it points to right now. To do this, you just need to refer to the pointer itself. Moreover, no additional symbols need to be added. To output the value it points to, we need to perform the process of dereferencing. And this process looks quite simple. We need to place an asterisk before the pointer. Again, remember that when we place an asterisk before the pointer, it's as if we're referring to the value it points to. And when we refer simply by the pointer's name, we're referring to the cell it points to. Let's run our project and see what we get. And you notice that the first 2 lines are output for references, and the second 2 are for pointers. Here, we have exactly the same concept. That is, our pointer has the exact address as our variable and the same value as the variable itself. Now, through the pointer, let's try to change the values of the variable itself. And every time we need to work with the value, we always have to write an asterisk, then write the name of the pointer, and then we can change the value itself. If we run our program, we'll see that the value has changed for both the variable itself and the pointer. So, the principle is the same as we had with references. Another nuance worth considering is that we can delete what we are pointing to. For this, we need to refer to ptrval and then assign it the value null ptr. Now I'm indicating that our pointer no longer points to anything, and if we run the program now, we'll see a slightly unusual result. This is because when I tried to output the value for the pointer, you see that now it doesn't point to anything. Now let's consider some small example of using pointers. I've prepared a small program for you using pointers with an array. So, on the first line, we declare our array numbers, containing 5 integers. Then, we declare a pointer, and want to assign it the address of the beginning of the array. That is, a pointer, named pointer, is declared, which has the type int. It is a pointer to an integer, and it is assigned the address of the first element of the array numbers. Then, using a regular for loop, we iterate over the elements of the array through the pointer. The expression, pointer plus I, accesses the array element that the pointer points to, taking into account the index I. Next, using the expression, pointer plus 2 is equal to 99. We change the value of the third element of the array, the element with the second index, through the pointer, increasing it by 99. And finally, what happens here is that we again use a loop to print our modified array values. The third element of the array has been changed, and we can see this when running the program. So, we run our project and see how the pointer is used to access array elements, and how changing the value through the pointer affects the original array. And overall, our lesson comes to an end. I hope you enjoyed it. If so, don't forget to subscribe to the channel and like this video. Until we meet again, goodbye.